Welcome again to our math tutorials. In today's lesson, I will teach you how to solve inverse variation in 4 steps. But before that, we're going to know first what is inverse variation. Assuming that this is your car, you're traveling at a constant speed of 30 km per hour. The table shown here, the distance and the time. In 1 hour, it covers 30 kilometers. In 2 hours, 60 kilometers. In 3 hours, 90 kilometers, so on and so forth. The two quantities increases. Remember this kind of variation? Direct variation. For instance, you're driving home. If you decrease your speed, the time you get home increases. However, if you increase your speed, the time you get home decreases. How will you describe this relation? Relations like this will be discussed in this lesson, inverse variation. Suppose you are going to renovate your house. Like Michael, he wants to have an extension of his house. So he needs number of workers to realize this on a target time. As the table shown here, the number of workers increases while the number of days decreases. This type of variation is called inverse variation. Inverse variation, it is a mathematical relationship between two variables which can be expressed by an equation in which the product of two variables is equal to a constant or constant of variation. In our illustration, the number of workers increases while the number of days decreases. In other words, as one quantity increases, the other quantity decreases. As one quantity decreases, the other quantity increases. That's what I mean inverse variation. Inverse variation occurs when one quantity is equal to a constant times the inverse of the other quantity. It has statement varies inversely as inversely proportional. If we translate the quantity varies inversely with x, if there exists a non-zero constant k, we have this equation. When we say y varies inversely with x, we can say this one y varies to the reciprocal of x. That's why 1 over x. Constant times 1 over x. 1 over x is the reciprocal of x. If we make this into a fraction, x over 1. So the reciprocal of x over 1 is 1 over x. That's why constant times the inverse of the other quantity. Constant times the inverse of x is 1 over x is equivalent to y, or y is equals to k over x, because k times 1 is equals to k over the denominator x. Here's now the 4 steps to solve inverse variation. Step number 1, make table for the given. Step number 2, determine the constant of variation k using the formula k is equals to x times y. K is equals to xy, or just simply multiply the first part of the given. Step number 3, translate the statement varies inversely as into equation and assign the value of k to that equation. Last step, number 4, assign the value of the last part of the given to the translated equation. Operate them in order to find the unknown. Let's go now to our examples. Example number 1. If y varies inversely as x and y is equals to 48 when x is 10, find a. the constant of variation, b. equation of the relation, c. the value of y when x is 32. For our solution, we're going to use the 4 steps. Step number 1, table for the given. Y is equals to 48, x is 10. What is y when x is 32? Step number 2, constant of variation. K is equals to x times y. So assign the first part of the given to the equation. 10 for x, 48 for y, or just simply multiply them. 10 times 48 is equals to 480. That's the value of k, our constant of variation. Step number 3. Equation of variation. Y is equals to k over x. We just simply translate y varies inversely as x, or y varies to the reciprocal of x. That's why x in the denominator. Y is equals to k over the denominator x. So assign 480 to k over x, and this is now our translated equation. Step number 4. What is y when x is 32? We use the translated equation. Just copy here, then assign the last part of the given to the translated equation. X is 32. So what is y when x is 32? So divide them. 480 divided by 32 is 15. The value of y when x is 32. Example number 2. The number of hours t required to finish a certain job varies inversely as the number of persons n on the job. If 16 persons require 18 hours to finish the job, how long it takes 64 persons to finish the job? For our solution, we're going to use the 4 steps. Step number 1. Table for the given. Number of persons n, number of hours t. 18 hours, 16 persons. Unknown t for the 64 persons to finish the job. Step number 2. Constant of variation. K is equals to t times n. Or use the first part of the given to the equation. 18 for t, 16 for n. Or just simply multiply them. 18 times 16, we have 288, the value of k. Step number 3, equation of variation. We just simply translate t varies inversely as n, or t varies to the reciprocal of n. That's why n is in the denominator of this fraction, k over n. Assign 288 to k over n, and this is the translated equation. Step number 4. To find the unknown t, find t. Assign the last part of the given to the equation, or to the translated equation. So the translated equation, we just copy here and assign the last part of the equation to the translated equation. 288, 64 is the value of n in the last part of the equation. We divide them, we get 4.5 hours, or 4 hours and 30 minutes. These 64 persons finish the job. I have 2 numbers here for you to solve. Please don't forget to use the 4 steps. Remember, inverse variation, as one quantity increases, the other quantity decreases. Or, as one quantity decreases, the other quantity increases. Same in our illustration, the number of workers increases while the number of days decreases. Inverse variation. Again, this is Sir Matt Knights. Thanks for watching.